Hello friends, today we are going to know the velocity and acceleration analysis. So this is the example number 1 wherein we can see the crank of a slider crank mechanism rotates clockwise at a constant speed of 300 rpm. The crank is 150 mm and the connecting rod is 600 mm long. So this is what is given. So we have to find linear velocity and acceleration of the midpoint of the connecting rod and angular velocity of the connecting rod at a crank angle of 45 degree from inner dead center. So this is what we want to find. So first of all you have to find out the angular velocity from given speed, that is angular velocity of B with respect to O is 2 pi n upon 60, n is 300 rpm. So substitute and we get the value 31.42 radians per second. And you have different lengths of the links. So it is OB 150 millimeter, you convert into meters and we get 0.15 meter. Similarly connecting rod length is 600, so you will get 0.6. The first step in the analysis of mechanism is you have to first draw configuration diagram. So you have to take scale 1 centimeter equal to something. Then step number 2, you have to find velocity of an input link, and it is given by V equals to omega into R. Omega is angular velocity of a link into its radius, that is OB, will give you velocity of B with respect to O. So this indicates magnitude of the velocity. And step number 3 is you have to draw velocity diagram. So let us see how to draw velocity diagram. So this is a space diagram, or it is also called as a configuration diagram. So you can see this line which is perpendicular to link OB indicates the direction of velocity. Why it is towards right only? Because the crank is rotating in clockwise direction. So the velocity will be perpendicular to the link OB and in the direction of rotation. So this is the velocity of B with respect to O. You know magnitude also. So by taking scale, you have to take scale for drawing velocity diagram. So in this configuration diagram you can see O is the fixed point. So I have taken this point as O. From this point O, you have to draw one line perpendicular to OB. So this is a perpendicular to OB I have drawn here. And the length of this line will be equals to the magnitude of the velocity. So velocity VB, you know. So by taking scale you will get the length of this vector. So this is O, this is B. Vector OB represents velocity of B with respect to O. Next one is velocity of A with respect to B. I told you already, velocity of A with respect to B is always perpendicular to AB and passing through point B. So you have to draw line perpendicular. So this line is perpendicular to link AB. So from B, draw line perpendicular to AB, which indicates velocity of A with respect to B. Now, but we don't know the magnitude of velocity of A with respect to B, but we know direction. So I have drawn a line. But at the end, there is a slider A. This slider has a definite motion along the horizontal line. So you know this slider slides horizontally. So from fixed point O, draw one line parallel to the direction of slider. So it will be like this. And the intersecting point of these two will give you point A. Now if you want to find velocity of point D, so this point D is midpoint of AB. So this is B, this is A. You have to, by using the ratio BD by BA equals to small bd by small ba, you will get distance from B or A, and by knowing the distance you can locate this point D and then join to the fixed point O. So this line will give you, this vector will give you velocity of point D, and when you label all the points you will get all these velocities. You have to just measure the length of the vector, multiply with the scale, and you will get the velocity. So this you already know. Now to draw acceleration diagram, you have to first prepare this table wherein this is link name, link length, then you can measure the velocity of link OB/AB from the velocity diagram. So this is very important. You have to find it from velocity diagram, and you have to measure and multiply with scale. You will get directly the velocities of these links. Now the next one is acceleration has two components, centripetal component of acceleration and tangential component. You know that. So this centripetal component of acceleration is given by v square by r. R is nothing but link length. So this is length of the link. So v square by r will give you centripetal component of acceleration. Since you know velocity of OB, velocity of AB, it means you can get centripetal acceleration of B with respect to O and A with respect to B. Now the last column indicates tangential component. Unless and until you know angular acceleration alpha, so the tangential component of acceleration is alpha into r. R is length link, so this is LL I have written here. So tangential component is alpha into r, but alpha is what? Angular acceleration. If you know, you will get the angular acceleration, but since it is not given, it will be 0. So there is no angular acceleration in this case because the link is rotating at constant velocity or speed. So after preparing this table, let us try to draw acceleration diagram. So for acceleration diagram, it is again I have shown configuration diagram because it is needed to draw acceleration diagram. So before we draw this, let us first discuss about acceleration. Acceleration of B with respect to O, we will have two components, I already told you. But since there is no angular acceleration given, alpha is not given, so it will have only one component of acceleration, that is FC, centripetal component of acceleration. You know the magnitude, and that centripetal component of acceleration acts from B to O. So remember, this is B to O, so you have to draw one line from B to O. So you have to take fixed point O here, and then you have to draw this line. So this is drawn here. So this is O, you know magnitude. By taking scale, you will get this line, and this is point B. Now acceleration of A with respect to B will have two component of acceleration. One is along this line, that is centripetal component of acceleration, perpendicular to AB, tangential component of acceleration. So let us draw. Now out of these two components, I know only centripetal component of acceleration. So the line I have to draw parallel to AB from B. So let us draw. So this is the line which indicates FCAB. And the tangential component, I don't know the magnitude, but I know the direction. So let us draw the perpendicular line. Now the slider slides horizontally, you know. So from this fixed point, you have to draw one line parallel to the direction of sliding. Now you can see this is FC, this is FT. The line joining these 2 points indicates the resultant. Okay, and after knowing, you can get the point D by ratio formula. You know that after labeling all these points, you will get this acceleration diagram. So I hope you understood how to draw the acceleration diagram. So you try it. Thank you.